Okay, so everybody run, create an error also. First, you will get an error. So I have written here, I am read for is not applicable for the DICOM image. Okay, I think all of you are able to access now file. To run these examples.
Sir, can you share it in the chat box because I have not received the mail yet.
Okay. Just. Yeah, hope so all of you have received this. So just pass this 2-3 commands. Okay, so 5 minutes I have taken the setup. Now after that, pass this command. Okay, so yeah, open it. Let us open it. Okay, so just see here. Yeah, everyone run this. Everyone able to access this now. Hope so all of you have accessed this folder. Okay, now after that, okay, fine. Now after that, yeah, this is all the information. Modality is a CT scan type, conversion type, manufacturer, where institution use, all the informations. Then the study institution UID. So you can change it. So also we have a workflow. So how to change the DICOM series, that can also be done. Okay, and then after that you will get a bit allocated pixel representation, all the detailed information about the image by the passing a command dicom info for that particular image. Okay, dicom image, we can do that. Okay, so these are the things we can do. Okay, so now after that we quickly understand. So no, normalization, set the pixel value of image where the highest value, lowest value of the size, and what is the size of my image. So if you go above, then it will be the 512 and deep depth is a 6 and format version is 3. So I'm just using the maximum, minimum and mean value. Now I am going to calculate some statistical features. So just calculate what is the maximum value of my image. That is a 4080. What is the minimum value? I have taken the all the row and column. Okay, so 4080 maximum pixel value, and then again you have a minimum value is 32, and the mean value of the all pixel value is 712. Okay, so this is a three. If you pass these three commands, you are able to know that. So you have to just simply pass the command max parenthesis name of the arguments where you have to store your image. Okay, and the colon. Okay, and bracket close, parenthesis close, again parenthesis close. That's all. So similarly, you can apply for the minimum also. So just pass a command min. Already I have written, you have to just run it. That's all. And then it will be 32. Hope so all of you have understood what I am doing. Image normalization. Okay, just why I want to know what is a pixel value of my image and all the things. Then mean value. Okay, so everyone run this. Are you able to get this information for this particular image, or you can also do for your own image also? No problem. You can go for your own image also. Later on, you can apply these things to your own images. Okay, so I think all of you will get it. So I'm calculating the maximum, mean, and the mean value. Now after that, I'm converting this grayscale. Maximum is 40 and minimum 32. So normalization, we bring 0 to 1. Okay, so to matte to gray. So I'm just converting into the grayscale image. Okay, and just converting to the gray so that 0, 1, 1. Here your value is larger. Now all the value will in between the 0 to 1. Okay, so normalization is required, and you may find out what is now minimum and maximum value. Okay, so 1 and 0 and mean in 0. This for the analysis purpose, this step is important. Okay, so yeah, so now see here earlier when there is no normalization, gray is not converted, then this is a 4080 and 32. Now after that, after the between the 0 and 1. So all value, now see here, I have just passed a command I2 and now create another variable name I2 underscore normal with all the column and row. That is a colon, blank colon. Okay, so similarly, I have passed minimum I2 normal and then minimum I2 normal. Okay, so and then 0.19, 0.11696 that I also pass. And see the again see the image after the normalization. So what will be the normalization? Will any changes in the image or not? So just see that. So that purpose I have normalized it. And now see that you may find out there is no major changes after normalization and before normalization. Okay, so this is a fact. So let us do, yeah, up to that normalization, everybody done? Okay, fine. Okay. After normalization and before normalization. So this will give you the better information. Now, median filter and noise. Now, next things everybody try to do. So add the salt and pepper noise to that image. So create another variable name j underscore noise. Use the function im noise on the normalization function which just above we have created I2 normal, and salt and pepper we will apply with the 0.02 value. Okay, and then try to run this image. So what will be happen? So we have created a noise in my image. Okay, so this is the thing. Now we apply. Let us understand some filters. Okay, let us understand some filters. Hope so. Flow is going very smoothly. Everybody able to run the program and understand the code as well. Okay, codes are very simple. I've just selected this code to understand. Now I am show and I'm using the I am show function and j underscore noise. That's all. Okay, so here you may find out lots of salt and pepper noise has been appear on the my original images. Now we can apply the filter just for the understanding the flow. So now this is the mid fit function I am using. Okay, by the 3 by 3 values. And now see that after that some noise I am so filtered image. So now you see that some of the noise has been removed. Okay, so are able to first I have created the blur the image or created some noise in the images. After that, I have applied the salt and pepper noise, and then I have to filter out with the help of this function made fit. I have made fit this function. I have used this to remove the salt and pepper dot black and white dot noise. Okay, just try to understand what I'm how this everything is going on. Now after the Gaussian filters, we can apply the Gaussian filter as well. Okay, and changes. What is the changes happen like that? and then see that in the Gaussian filter you will get a better result by the use of the this filter, average filter. Okay, the Gaussian filter is looks much better than the made fit filter. So everybody try to run this up to this only Gaussian filter. That's all. That also be done because Gaussian then Kalman filter can also be applied. So and then other thing we will do then after the next task will be the how to calculate the voxel value using the DICOM info, find out the volume, width and thickness and all the things. Yeah, everyone, are you able to run this code? This is the code. Just I have randomly make a one flow to understand. Yeah, anyone reply me? Everybody has run. Okay, fine. Thank you. Thank you. So very simple. So not very long. Thank you. Okay, so yeah, so we will quickly jump to the another part. It's a very interesting part. So yeah, so come here and again open your code. In folder and see add to the path. So now everyone open the segment the lung from the this folder, this example. Okay, so biomedical we have classified the breast tumors. We at the moment we are not going to take. So open this segment the lungs from this 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 one. 3D chest scan example .mlx. Everyone open this example. So now all of you start doing this. So I have this is the path, okay, where the data will be downloaded and all the things. Okay, so this is the zip file. We have taken the total size of this zip file is 89 MB. So we have simply, so what is the purpose? 3D chest scan and the segment the lungs. Okay, so by use of first we do with the programmatically, then we will go for the app. In the app section, if you find out in the app, you have a various apps. Yesterday I have also explained, we are going to explore, go to the image processing segment. Okay, and then image medical image labeler, volume segmenter, volume viewer. These are the apps are the important and DICOM viewer, DICOM browser. Okay, so these three apps are the important for the medical images. Okay, volume segment, volume viewer, medical image labeler, and DICOM browser. So these all apps are available in the app section if you install the medical image processing toolbox. Okay, so just simply run this. So segment the lungs. So we have to segment the lungs. Yeah. So here you may find out one folder with the zip file. If you extract outside of the volume, you can do that. Okay. So yeah. So if you want to check, then you can extract outside of the MATLAB and then pass a command. Sorry. Now this is the volume viewer. So you have to just run it and programmatically also you simply type of volume viewer on the command window with the which image you want to explore. Just in the parenthesis, you just type it. So volume viewer app directly open. Okay, without going to the app section. You just pass the command volume viewer. Okay, now see the properties of the images. So chest volume. So this is the folder which has images of the chest volume. Okay, so load the chest volume and whose command by knowing the what is the variable. So if you pass a command B, then it will give you the return back the value with the size. Okay, 512, 512, 318 bytes and class. You just remove this semicolon, so you are able to see the pixel value, but do not remove it. But that information we do not require at the moment. We require this volume viewer, this one. See, it is a running. Otherwise, you can directly open the from the app. Go to the app and from the app directly go to the image section and from there you can directly open the volume viewer. Image processing and here you have a that app. Or simply click here, you are able to access the volume viewer. Once you open the volume viewer, yeah, anyone facing any difficulty getting an error in volume viewer app is not supported in on MATLAB online. Okay. So in that case, you have to switch to the desktop version. There's no help in this because it's not supported. Generally, I'm not. Yeah, so it's not supported. Then the MLX file I have already shared with you. Now here, very flow manner I have shared with you. I have mentioned everything over there how to open it. So let us understand first volume viewer. Okay, so now if you open this, up to this everybody has no. So what you can do simply, as I have already p is the my variable name where the my image data is stored. So simply it will open from my volume viewer. I have shared very well written code, so you will get a very good understanding. Even though when you switch to the MATLAB downloaded version, so you can go from there. Okay, so volume viewer is opening. The limitation with my PC is that I do not have any GPU, so CODA enable things I cannot able to do that on my PC. But if you have, then you can proceed further. Now see here, this is a very useful interface will be open. Okay, so yeah, you have lots of options are available over here. So if you have a XYZ, XY plane you want to view, so I have there is no need of the importing over here. You can import from the file, type from folder, import from workspace from the file. You can import it from here. Okay, then various options are available. 3D displays can we can do that. Okay, so this is the functionality of the volume viewer. Okay, so XY and the YZ plane. Okay, and then XZ plane as well. So if you increase and decrease, you can easily visualize the your image over here. Okay, so what exactly the image is there. So now if you click over here, you are able to see the yeah, and then YZ plane, मतलब side view. That you can see that and 3D volume. So you have this option. You can, yeah, so this is the things you can do over here. Okay, so but here if you go better understanding, go for the city pole. If you click on the city pole, then the better visualization will be come into the picture. Okay, so just see here. So this is the 3D visualization of the lungs. Okay, so this is the lungs. The we have to segment the viewer. Yeah, those who have working with the downloaded version, are you able to find out this? Or you can customize the this value also if you want to uh, put this image intensity like that. You want to image intensity customize, you can customize also. Just click here, each or whatever you want, so that the proper can be done. So yeah, this is the volume rendering can also be implemented. Okay, now see here. You can customize it also. Okay, so you want to set 2 by 2 grid or slack 3D slides, that can also be done. You want in the side view and all the things will come over here. So that can also be implemented. Okay, so whatever the visualization of the your image, if you want, can utilize, then customize also. Okay, intensity value, how the intensity value will be suitable for you. Okay, that can also be done. If you want, yeah, so this one, so further if you reduce this value like that. So I say that this is a matter of practice. Once you know where the tools are available, then after that the practice can be done. So from the practice we will do so many things. Okay, so this is there. Once this is done, so city bone you have to select and such a type of the intensity level you have to set. Okay, so yeah, again come here and then select the maximum in isosurface level rendering and everything. Again come back here and then again see the city board. So better yeah, better flow. Okay, this is the use of the volume display. Okay, now go further. Again I will jump to the code. Okay, so I have written over there everything. So now segment the lungs. Okay, so for that purpose, so we are using the active counter approach. So this is the segmentally we have to do. So, so first of all, we take a 160 value XY plane, then YZ plane, XZ plane, and then figure I want to show plan IM show function I'm using display by the grayscale images. It's look like this. Okay, so brighter view and then the lighter view also. So all of you. Then after that, open the any model. So yeah, so all of you able to plot XY model, squeeze view, and then after that visualize any XY model. This is the chest. Okay. Fine. Okay. So now it's time. My image is imported from the zip file. It is imported. I have visualized my image, and then it's time for the segmentation. Okay, so I have told you, if you directly open the app and then image segmenter app is there, or directly you can write a simple image segmenter, open the normal image. Along with that, I have passed my XY view also. So what I can do, simply I run it, and then what you can do, simply use the, yeah. So first of all, try to run the command. So image segmenter will be open. Hope so I am able to explain the things in area you are working. Image segmenter, so XY plane image segmenter will be open. This is the, by the command line it will open. Okay. So interactive way we are doing, otherwise the code is there. Through the code also we can do. Now see that I have already explained. Go to the app. Under the app you can also access image segmenter in the app section. Go here, and yeah, image processing computer vision section, and you have a image segmenter app. If you directly click here, it will be open. If you do not want to do like this, so simply pass a command image segmenter, and I have on XY model also. Here XY object is already created here. You see in the workspace, yeah, XY side image is already created, so that I'm directly opening with that image directly. Otherwise, if you open here, then pass a workspace variable XY. That's all. So this is the thing. Now, once the image segmenter is open, so where is the image segmenter? Ah, yes. Would you like to increase the image contrast? So yes. So we'll try to increase. It will automatically adjust your image contrast so that it can be you can view it clearly. Now this is the image segmenter. Okay, so yeah, so we have a four options. Let us suppose, Jones, before coming to this page, I want to explain some image segmenter part as well. I simply search here inbuilt function, and then I will open the help button, image segmenter. Okay, and click on the learn more. So three things, the three apps are there for the image segmenter. That type of operation we can do. Okay, yeah, image segmenter close. Here you'll get a, yeah, getting started with the image segmenter. Here the things is there, so we can do segmenter, anything model, thresholding, graph cut, auto cluster, find circle, local graph. Okay, so these are the find the field. If there is any fields are there, that you can draw the ROI. Okay, so these are the operations we can do in the image segmenter. Okay, so yeah, everyone. Now this is small information about the image segmenter. Now let us do the practically. So I have already opened the image segmenter. Okay, so here you have options. Load the mask, load the image. I have already loaded from my program. Okay, now we are going to perform. You have this type of operations you can do: create thresholding, graph cut, auto cluster, find circles. So here I am going to do thresholding operations. So I am going to click on the threshold. Now for the threshold have a three options. Okay, so now see here, once I click on the threshold, new interface will be open in the same image segmenter app. Now see here, global threshold. Yesterday I also explained this part: global threshold, manual threshold, and adaptive threshold. Okay, so for this demonstration, I will select the manual threshold option. manually we are going to do. Okay, so yeah, so this is the threshold. You can increase and decrease the value. Just see here, you can increase the decrease the threshold value, or like that. You can adjust as per your requirement. Show the binary. If you click on the show the binary, so still we have able to create a perfectly segmented. Okay, so manually you can increase or decrease the value from here. So you can able to do that. Okay, so which value I have taken in the example? I have taken here example 550.9. Okay, so manual threshold I have selected. After that, manually I am increasing and decreasing the threshold value where I am getting the desired segmentation. Okay, and after that I have to click on the create a mask. So these three steps we have to follow. Okay, so just set the value 50. It's also manually you have to apply. It's not a fix of things like that. Maybe answer 5060 how you have selected this value. Okay, so I have yesterday I have explained the concept. Yeah, I have that concept how to. This is the your manual understanding visualization. Okay, so visualization of, for the image and all the things. Once you do lots of thresholding operations, you will get idea. Okay, so now show the binary I already showed. Okay, now after that, once you are satisfied, yeah, I have properly segmented. Okay, so now click on the create a mask. Once you click on the create a mask, then further things will be appear. Okay, further operation will be appear like add to mask, create a mask, define the mask. Okay, so we will use here invert the mask. Another option we will do that morphological operation can also be do. We will do that for the another part. Okay, so I will do the invert the mask, that operation. Okay, so yeah, so I'm doing the invert the mask, and after that in invert the mask, what can I do here? You have to include the textures, features, and so many things here: segment, graph, field, draw the ROI, interest of region, show the binary and all the things, and after that export you have a two options. Generate a function. It's a very good thing. You can customize it, whatever the things we have done. If you want a code behind that, whatever the things we are performing in terms of the code, it directly generate a code. Okay, so we have save our time over here. We can save our time over here. Okay, so then after that, so now see here in my code also, I have explained here these four operation view. If you go manually there, so I have used this function. Xy is greater than 0.9098. Okay, this threshold value I have taken. And then after that, I have cleared inverter mask. And for the inverter mask, you have to do clear the borders, first pre-processing technique you have to perform, then fill the holes you have to perform. Okay, and then clear the borders. Yes. So invert the mask, then after clear the border, again come here. Now you have the option here, clear the border. You have the option, clear the border and fill the holes. So click on the clear the border. So whatever the clear is coming, so we have a main focus on these lumps, right? Okay, so it's now you may observe that is clearly segmented. Now you may find out here lots of still some holes are visible over here. Some holes are visible over here. If you see that, if you zoom it, you now see here there's a lots of holes are available here. Okay, These holes are available. Now here is also holes on left hand side and right hand side. Further zoom it, you will get a better idea. Okay, this side also, left side also, and the right side both. So yeah, so this is the thing. Okay, so now what we can do, we can fill the holes also. Whatever the holes are available, that we can choose that holes also. Now see that. Now you may find out here the now whatever the holes which are available at that time, it's get filled. It's get filled. Okay, like that. Okay, so that I have also mentioned in my code. Okay, so fill the holes. So yeah, sit on. Now you will get a this type of the image when you and here the same code. If I generate a function, that function has a this code. PW is the name of my segmented image. Then fill the holes, take a radius. Now morphological operation. And now see here, refine a mask after this initial lung segmentation. Clean up the mask option, refine the mask. Okay, that option we have completed. The app is already executed that code and the answer is in front of you. Now it is for the XY. So now see here, if you go to the binary, so same thing you are able to see which I am in your the code as well. Yeah, is it problem any to understand this? How I have segmented, how I have used these two tools, volume viewer tools and image segmenter tool. Then I have applied the thresholding. After the thresholding, then the other operation I have done. Okay, I have done the invert the mask, clear the border, fill the holes like that. Yeah, done. Okay, fine. As okay, fine. So now after that, we'll move ahead. Now at this time, this is for the XY. Now see here, this is the XY segment. Now for the other, so for the other, so we have to perform these operations. Okay, just I will run it because I have already run this program, but I will show you how I have done this. So what I can do in this sequence, yeah. So now XY is over. Now go to the load the image, click on the load and select from the workspace. For workspace, I have already loaded the XY. Click on the workspace. Yes, continue. Because already I have imported to the function. To the function, if we click the generator function, okay, okay, fine, fine, okay, fine. Because I have already click on the function and bring all the files over here. I have made a copy paste. Okay, that part I have done. I will show you here also. So which part I have covered? So XY is over. XY part is over. Now exit. Select this exit. And click on the OK. Now, yeah, adjust the contrast. Now, this is the XZ view of your image. Okay. Now, last time we have done with the manual approach of the segmentation. sorry, thresholding. Under the thresholding, we have done the manually. Now this time we can do the manually. We go for the some other options. Either we can go for the global or adaptive. So both the things we can do. So yeah. So again, come back again, open this. Yeah. So we have to use the global threshold option where I am binarized code. They are using it. Okay. Then after the erosion, the operations of the morphological tab and radius to the 13. Okay. So that part we can do. So, so now here volume viewer is over. So I'm just closing this. Now it's here. Okay. So I will go for the global threshold. Go the binary. Create a mask. Click on the create a mask. Okay. And then this time morphology operation we can do. Click on the morphology. Select the operation erode. Click on the erode. I'm not fast. I'm just click the option here. You have lots of options. When you click on the morphology operation, thresholding, after thresholding, last time, then here I have to click on the erode the mass. Click on the erode the mass. Under the erode mass, select the radius value 13. Okay. Apply. If you want to take a disk space, square, octagon, line, diamond, all the things are available. Now I already applied and closed the morphology operation. If you want to export, click on the export, generate a function. We were able to generate a function. So this is the function which are generated. So simply I have copy paste and I pasted on my .mlx file. Radius string decomposition 0. Stall function I have used. I am erode I have used. Text image x and text image 0. Okay, so this is the code behind that app is there. Okay, so this is the function mask image segment the image x. This is the function sir it's creating. Also understand how to generate the function after the operation from the app. Earlier we have to write this image, but interactive way we are not able to understand. Okay, so app has a role. Now, now come here. Now we have taken the binarized image. Okay, once I have a segmented image available, now segmented image. So we have used this function active counter. So whatever the holes are there, then they can be active counter function I am using here. Okay, font size and mask image xy. Okay, then histogram equalization, voxel value, available range that I have used. And then I have used the function active counter. Okay, I show you that option is available. Then I apply to the my segmented image. Okay, and then after the segmented image, now I am viewing in my volume viewer segmented image. That's all that I have done. Okay, so again, it will take some time to open it. Okay, so everybody try to run those commands. If you find error, then error will be related to the tools. If it is there, I think so. The no error will come. This is the output you are going to get. XY segmented value XY plane, and then the XZ plane, and this is the 3D volume of your complete lung. Okay, and then after that you have to calculate the pixel value, and it's can calculate the lungs volume per liter. 5.77 is the value you are going to get it. This is the command I have just passed, gx, gy, z, and I have multiplied all these values. Okay, region loops. So just pass a command, region operation. So I don't know about that. Then what can I do? Simply right click, and help on the region. Still, the code is running. So we will see the further line of code. Okay. So all of you understood the how to calculate the lungs volume. Okay, and I have used the different apps, loops, and function as well. I have explained all this part under this. So you have to do frequently. If you implement this type of the code, then you are used to understand these apps. Okay, and these workflows are very simple. If you want to know further in these segments, if you want to know further things, so I will tell you again. Yeah, still code is running. So simply go to the command window. Go to the command window. Or simply pass the command. Yeah, sorry. Proceed. Code is running. Came here. Then if you go to the, I've already passed that command. Okay, so go to the image processing computer vision toolbox. Okay, so this is the complete set of information of the MATLAB. This is the image processing computer vision, and then you have a here, medical image toolbox, which I am talking. Yesterday I have talked about image processing somehow computer vision as well. Today I am talking about the medical imaging toolbox. Just click here, medical image toolbox. Okay, so you have all these options. Display, registrations, making the medical image labeler, and labeling the segmentation and analysis. Okay, so that part have been implemented. Just so that all the things are there, getting started, import the image, display the image, process the image, then making an analysis application, cell code, microscopy segmentation as well. Okay, I click here, getting started. Then we have lots of things over here. Okay, samples. Then the getting started with medical imaging. Then we have a diagnostic system, biomedical engineering, personal analysis, pharmaceutical research, device design. Okay. So, so these are the next generation, is a very emerging area. Diagnostic brain MRI scan, breast ultrasound images. Okay. And then the functional system, brain functionality, Alzheimer disease analysis. Okay, so you have this is a different types of modality, whether you need the CT scan, MRI scan, PET scan, ultrasound, X-ray, microscopy analysis. I'm just trying to explain this flow. I've imported the data with the help of medical volume, medical image, medical 3D. Then after that, displaying and editing the surfaces. I've used pre-processing it.
Halo, 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 halo. Coba, 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 coba. Manggap terconula.
Okay, so these are the things I have explained to you. Okay, so getting started, let us want to explore the CT scan, then the interactive medical image labeler 3D volume concept. Programmatically, you can do then the medical volume labeler, and these are the examples are there. So if you want to do the Pune labels, that can also be done. Okay, then the PET analysis, ultrasound image analysis, the X-ray. Just simply click on that. So I'm sharing this link to you. This is really useful. Okay, so yeah, so just I copy it, try to run this model and put it in the chat box so that you can further utilize this. Okay. Okay, don't worry, I have already run this program. So this is the value I'm getting. Okay, fine. So let us explore this ultrasound image. We process view the ultrasound. So simply click over here. Find the ultrasound, then what is the name, then how to visualize all the scenes on and displaying what images. Okay, and the user speckle noise, support the smoothen data as a medical device object for the further use. First of all, we will start with this. Okay, so we use ultrasound images. Is there any doubt in the volume calculations and the files? So hard ultrasound sequence video, so hard. Then after that, medical image file name I have passed. So yeah, this command I have passed. Get to know what is inside this file name, what is inside this the information. We have a images for that value, color map, spider node, pixel modality use, and the other details. Then after that, we use the montage command, display all the images one by one, side by side. Okay, so this is the command. You see that now stored as an ultrasound series as a video. All these frames of the images or video frames now be displayed over here. Then up further you can do the segmentation of the left, left, left hand of the heart, the right hand of the heart, like that. Further analysis we can do the speckle noise and show the smoother data as a medical image object. So then again further see that and display as an image. Okay, so this is the one more examples. Volume viewer. Slow run, already run. So this is the final data we have able to achieve. Taken a time because multiple commands I have passed. Okay, that's why so 5.726 has come. And then this is the volume viewer where you can get view. This is the last exercise. But if you do the city mode, then you are able to see this. Clearly segmented. You may observe that clearly the lungs are visible, which is the earlier was not visible. Okay, you can do further modality analysis of this. Oh, fine. So this is the one examples I have taken. Okay, fine. So I'm closing this. Any doubt? Anyone? Please ask. Any challenges? Including all these apps as of now. Okay, I have already shared the course with you. So all the things is with you. Yes. Good. Now, yeah. So now come to the documentation page. As I already talked about that. Okay, so here we can do further things for the analysis. For it will be done. So now it is time for the switch to the AI. Okay, so yeah, for the so many examples are there. So due to the time limitations and all the things, I'm just sharing. Yeah, I will share this also with you. Sorry, not this one. This one. You can save these links for the future use. So where you can find out the medical images related flow. Okay, in these two links, all the much details are there. We can pattern reference, display the volume data which we have done. Okay, pre-processing argumenters, we have done argumenters. We can do, and then further other labelings are we can do. MRI segmentations, and then yeah, so this is the new examples. Maybe the retinopathy, diabetic retinopathy, multi-level fundus image classification you can do within the deep learning. It's a very good examples recently added. Okay, we will explore this part. So now let us start the AI part. Any problem in the medical images? Any doubt? So I have shared a maximum link with you, so which is a really useful for your understanding. So let us jump to the AI part. Under the AI part, then I have discussed about this thing. Okay, I have explained the general workflow. Now AI part is remaining. So general AI workflow. I have explained that. Just a minute. for the application of AI, the various things has been developed. Okay, I'm switching to the AI. Quickly, I will give you introductions. Deep learning for the robotic arm, augmented reality of the blood flow, CNN for the digital pathology analysis. Okay, machine learning for the blood results. Okay, these are the some area where the lots of industry has implemented these things. Okay, so artificial intelligence, some basic definition we will start. So artificial is a very big where the ability of digital computer or robot perform the task which commonly associated with the intelligent being. That's simple. But mimic the any system which mimic like an intelligent human, it's called as artificial intelligence. Okay. Machine learning is a subset of the artificial intelligence where the computer PC understand learn the task from the data without relying on any predetermined equations. Okay, or equations or model. They learn the data from that. So this is the simple definition of machine learning. And of course, deep learning is a type of, is a subset of the machine learning where the feature extractions can be done directly from the data. So there is no type of machine learning which model learn and perform the task directly from the image, text, and sound. Okay. So this is the some basic definition of these three common. So our the thing somewhere we can apply the machine learning as well. Somewhere we can apply the deep learning as well. Okay. So yeah, of course, ability to learn from data inherently without being explicitly programmed. Learn the complex nonlinear relationship. Whenever the machine learning we apply, where the equations or data will be very complex or too large, at that time we can apply the machine learning. And in the machine learning, manual feature extractions is required, whether it is an image, signal, or anything. For deep learning, the manually feature extraction is not required. The model itself extract the features. So just see here, this is the input images I have given to then I have to give the different features and then the classification algorithm of the machine learning and classify the what exactly the image is this, input image is this. Okay, and the deep learning, so it's subset of machine learning which has a black box type of the thing. So automatic feature extractions. So learn the features and tasks directly from the data, whether you are working with the image, text, or signal. Okay, so it may be the supervised, it may be the unsupervised or semi-supervised. The only thing is that in the deep learning, that the more the data, the better the model. That is all. So subsequently, then when you have a more data, then you have a storing capacity, and then of course you require the GPUs and the processors, good processors. This is the additional requirements when you are handling the. Sometimes you have to run the model and take very longer period of the time because it image maybe have a 1,000, maybe the 1 million. Then you have to use the cloud version support. Okay, so Dockers and the that type of the systems are there. You can utilize the Azure or the other cloud platform where you can run the model or like that. So generally, these are the things can be done for the deep learning. Okay, so yeah, so this is the time available required and data volume. You can use the deep learning and you can use the transfer learning with CNN and on LSTM. You can also use for the wavelength scattering, so automatic feature extractions. For the manual feature machine learning, we can apply, and the artificially we generate the code. Synthetic code can also be generated. Okay, so FDA, what does FDA think about the AI? So AI unlock the insight present in the vast amount of the data generated during the healthcare delivery because because lots of patients are there, lots of data are there. So healthcare associate cannot be done individually. So we require a one system where the AI play the greater role. In 2020 February, so FDA approved for cardiac ultrasound software that use the AI to guide the users. Okay, so like that, those lots of regulatory mechanism approvals we are getting about the AI and how you can apply for the medical field for the medical devices. Okay, so yeah, this is the things that focus on the images. Tomorrow, when Nikhil will come, he will focus on the signal. So wide variety of AI in the MATLAB, whether you are working with the computer vision, image control, sensor data analysis, sending volume, like that. So we have a very variety of the support in the MATLAB. Okay, let's see that. So these are the things are there. So, but we quickly jump to the yeah. So this is a quick introduction of the MATLAB and the AI for the biomedical. Now I will show you quickly how to use the AI where the resources are available and all the things. Okay, so just yeah, I have already shared with you the code. So in the MATLAB, yeah. So I have gave the here the codes. Like I have kept the stop. Here I have a I have shared the code with you. Just open that. Here lots of else I have. Folder I need to stop rules that simply paste here. Take a current folder. Take this folder current directory. Add to the path selected for that folder. Read here. The exercise and regression complete and the diabetics. The things are here. Then I will start with the classifications. Okay. So in that I will take a example of the Fisher iris. So you will have a good idea. This is the data set for the today's explanation. So let us understand machine learning through the app. Okay. So yeah. So before that, I will clear my command workspace. So cl clear all. I will pass a command so that all the variables get clear of the previous work which I have done for the image processing. Okay, so due to the time interest, so what can I do? I will quickly cover the confusion matrix. Okay, so this is a just quickly understand. So AI have explained machine learning and deep learning. So yeah, once my workspace get clear, yeah, now it is clear. Okay, so I will do with that. I have passed a command load Fisher IDs. Can also do that. Take a one MLX file and whatever the things I am explaining is already code is with you. Okay, so just pass load space Fisher IDs and just try to run this command. What happens? Two folders will be available. We quickly do that. I will not take that much time. So two variables will be appear. So maze and the species. Okay. If I open this maze, then you have a 150 by 4 type of the data. Okay. So now see here 150. This is the 4 column. So we Fisher iris data, length and width, sepal length and petal length, and sepal width and petal length. Okay. So yeah, so this is the dimensions of the flower. I think this is a very famous data set. You will be come across in program research. Okay, and this is the classes. Setosa, 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 Setosa. Up to the total 150 is there. Okay, so these are the things Virginica. So this is the two class. When you pass this command, then you have two variables. Okay, so basically it has a three flower, versicolor, setosa, and virginica, and their sepal length and the petal length. Sepal width and petal width. And it means the four column will come for the and three flowers, sepal length, petal width, and sepal width, petal width, like that. Okay, so yeah. So now after that, just do the data analysis part. So scatter plot I have plotted for all the flower for the sepal length and petal width. And now you may find out the here. So is there any information you are getting from this? You now see that the red circle is separated, but the virginica, versicolor and virginica is overlapping with each other. Okay, it means that Setosa has clearly identified, but versicolor and virginica is overlapping with each other. Okay. Similarly, you will get in the biomedical type of the data also. Now, so this is the scatter plot has done. Then this is the box plot implemented. Get to know what is the median value of my data, and then how it looks like. Okay, and then I have plotted the box plot as well, like that. Okay, so this is the simple EDA, means disruptive data analysis of my data that we have to do. And then after that, sepal and petal width we have done. Okay, so this is the distribution of my data. Now what can I do? Then further I have to box plot between the two variables that I have done. Now after that I have to make a table because this is a two folder. Then I make a single folder by using this command. Fisher table, and all these variables name. Sepal name, sepal width, petal name, petal, the species. Now see that this is the table. The sepal length is there, sepal width is there, petal width is there, petal length is there. Okay, and the species at the length. These spaces I have to identify. Now it is time to open the use the capability of MATLAB with the help of apps. Click on the app, go to the machine learning and deep learning section now. Earlier we are moving towards the image processing computer vision app most of the time from the last 2 days. Now it is time to know this channel, machine learning and deep learning part. Okay, so here you have a classification learner, deep network designer, deep learning will be done here like that. Okay, so here we require the classification learner. Regression is also there and the other models are also there. Just click on the classification learner app directly. Click on the classification learner app. Similarly, for the biomedical data also, you have to use these apps. Okay, so one app will be appear quickly. In that app, you have to pass this table only, this table. Okay, so this interface will be appear. If you have your data in the CSV file, then you can directly import. Turn the grammatically everyone. So click here, new session. Now two options you have. This is the interface of the classification learner app. Okay, so now you have a from workspace and from file. At the moment, I'm moving the workspace. You can also do from the file as well. So click on the from workspace. Click on the from workspace. So this another interface will be appear. It will automatically detect whatever the inputs are available in your workspace or whatever the variables are present in the your workspace. Okay. If it is not selected, you can do that. So just select here and click the feature table. Click on the feature table. Now see here, automatically sample length, sample width, better length, better width, and these pieces are unselected and others are selected. Only the response I have to find out. And the validations. So cross validations, you have four options: cross validation and the other holdout validation of things. We are using the cross validation over here and put the value near to the file. Okay. And some other value if you want to choose, you can choose it to you. And click on the starter session. Testing because my data set is very small, so I'm just for now I'm avoiding it and click on the test session. Now see here, here you have a this tab is appear now. Once you pass the value response and predictor value, now your PCA cost analysis optimizer and all the things are available. Okay, to save my time, I here these are the models are available. Okay, quick to train model, all linear model, decision tree, discriminant data analysis, then logistic linear regressions, and all the models are available over here. More than 20. Okay, so to sake of time, just I will select on the Alt quick to train. I will just select the all quick to train, and then after that I will came here train selected, train selected, and of course you have to understand the parallel pooling operations. Parallel pooling will definitely it will reduce your time. I will show you where it is. If you go to the MATLAB and then you have to go to the home tab, it is loading the data. Meanwhile, I will explain here. You have this option because your data set in the biomedical image data is very large. Okay, just see here. Here you have option parallel option. So select a parallel option, select a GPU environment. I do not have a GPU, so hence further option is not open. Okay, select the environment, discover the clusters, monitor the job and parallel settings are there. So that can also be done. Okay, so speed up your flow of your training data. So I have just selected the quick train to all. So they have selected the randomly any 10 model and less than that out of this total model. Around 29 models are available like KNN, assembler and all the things. Okay, because these other things are also there. Now see here, let us now this is the training is going on. Now you can observe here. This training is going on. All get trained. Which has the best value? It will be appear in the box. Let us start with the worst model first. Which one the first? Because here accuracy come to the picture and accuracy is always 100% generally that. So but here we will start with worst model. The 67% has come for the sum of the KNN model. I will click here KNN. No, see here, its values means statistics is coming. Okay, so now you get the accuracy, total cost, error rate, prediction speed, training time, all the informations you are get. Okay, so this is the worst model. Let us create the confusion matrix. Click on the confusion matrix. So now this is the confusion matrix for this particular task. Okay, so diagonally all are the true value and adjacent is a false value. So Sentosa has 40 times time correctly identified by the model, a KNN model, but one time it is a give the wrong answer. And again, 47 times again, versicolor, the model predicted correctly, 3 times predicted wrong. In place of versicolor, model predicted Virginica. And the next one is the Virginica. 5 times the model predicted correctly, Virginica, Virginica. Okay, but 45 times the model predicted wrong. As the in the scatter plot also we have understood that the problem is between the versicolor and Virginica. Okay, so this is the confusion matrix. Let us open the best model. Now, so click on the click on the efficient linear. Now you have my find out accuracy is 97.3 and other details are here. Okay, the prediction speed, training time, all the things. Now click on the confusion matrix for this best model after training, which has a 97.3% accuracy. Now see here, Sentosa is correctly identified, which is expected also. In versicolor, 40 times time correctly identified, but 3 times wrong identified. And the Virginica 40 times correctly identified, one time wrong identified for this particular model. Okay, efficient linear model. So quickly I have explained this part. And otherwise, if you go through the file also, if you have a data in your Excel sheet, so simply click here from file. Just so this is the model, and you can also plot the ROC curve. If you want to compare the result also, so click on the result table. You are able to see the all the model has get trained here and their values. Statistical values are here. Accuracy, total cost, like that. Here you have options, select option, plot the result, export to workflow, export to the file, like that. Okay, so here you have a result table for the all this model. Okay, if you click to train all, then you further information. Let us suppose you want to do further analysis, error rate, micro precision, and model size. What is the size of my model, train model, like that. Okay, that information you also give. Now, if you click here, you can generate a code also. If you click here, so you have a lots of options. You can put it to directly Simulink. You can go through the model, create an experiment, like that. So like that you can do, or simply click on the model on the workspace. After training this model, you can turn on the model, the workspace. Okay, so this is the classification interface. How this, if I click on the classification model workspace, the model train model name is a train model, like that. Click on the OK. The model get train model get imported to the workspace. Okay. Now, what I have not yet trained, I have done earlier. So see here, model get trained. Now you are getting the same folder, Setosa, Setosa, Setosa. And you can view also classification tree if you want to see. That can also be, you can view. Acha, code and graph is not there. Okay, fine. Okay. Now see here, this is the Setosa, Setosa, Setosa. So model the for 50, the Setosa is there in my date, and this is also. Okay, so like that, the confusion matrix can be implemented in the MATLAB. Okay, so similarly, we can go for the, yeah. So again, I help you to understand. This is the different apps are available. Okay, similarly, you can start with the experiment manager tab is there. Other thing, experiment manager in the MATLAB segments is there. In the machine learning, deep learning classification, I have explained. Similarly, you can go for the regression learner app also. Okay, then deep network designer. This is the where the you can train the model. If I simply click the, you will come on the deep learning as well. So I quickly, the time is over now. Whatever the I request, give me the additional time. Okay, so that the that part can also be covered quickly. Where the resources in the next speaker will come tomorrow, then they have to. So this is the general workload: prepare the data, train the model, and deploy the system. Okay, this is the deep network designer app. So just to do the start page. This is the deep network design. You can start with the blank model. Okay, then you have a lots of models are available. The different audio signals, feature classification. Okay, or even if you go the blank network on the workspace, from the PyTorch or TensorFlow, you can directly import a model here. Okay, then after that, in the image, you have a SqueezeNet or a train models are there, ResNet 50, efficient 50. This symbol is that the it not come along with the software. You have to download it after the installing the main MATLAB software. Okay, so you have to go to the add-on option which is available. Just type this ResNet 50 and it will get easily installed. Okay, so other models are there. Then mobile net V2, DenseNet, ResNet 18. Okay, inspections, VG, AlexNet, very small model is there. Okay, 227 by 227 type of data. Okay, if you click on the blank model, so here you may find out. So this is the thing. You have a input layers, you have a output layers, and in between them, you have a different types of hidden layers. Okay, just application of your brain. Okay, and each layers are interconnected, each nodes are interconnected, and this is the input to the hidden layer first layer, and further the hidden layers are also connected with the further hidden layers like that, and then at the end all these layers are connected to the output layer. Okay, so each node connected to the all the nodes of the subsequent node, and then like that the one network has this one neural network has been designed. So these are the AlexNet, BGG, BGG 19, Google Net, These are the model where you can start building your model initially. If you are new to the deep learning, then you should start with the AlexNet. Okay. And then after that, the others are there, ResNet 18, inspection, these are object detection or semantic segmentation. If you want to do semantic segmentation with the help of deep learning, then these models are there. Okay, and lightweight and computationally efficient, and you have a SqueezeNet, ShuffleNet are available. So these are the pre-trained network available for the public use. Okay, so this thing I have already explained. If you have a TensorFlow data, then you are putting to the ONX, and further it can be incorporated or interoperability with the MATLAB. Generally, there is a two approach in the deep learning. First is the deep neural network from the scratch. Okay, so you can create your own network like this. Like here is an input layer. We have to just bring this. Okay, so this is a deep network designer. So this is the input layer. This is this layer. Okay, then use some models from the convolutional neural network. Just select this. Okay, so you have to just connect this way. These are all are the input layer. So not connected. This will be connected. Okay, layer library. Now further, to move further, then the these are there. Again, go to the layer library. Then you will get a activation layer. Just click here activation layer. Further, activation layer. Okay, so like that. Create your own model from the plan, from the scratch, or otherwise you use the transfer learning model. Okay, so already in the domain, you have a lots of pre-trained networks are available. Use those networks to do your work. Either and auto arrange, auto rearrange. It will rearrange for you, and then you change these values. Like let's suppose you put layer, how much size of your image you can modify from here. Okay, then conclusion will let what is the deletion factor, what is the padding if you want to give or not, then weight size. So you can change the values as per your wish. Okay, like that. This is the interactive way of doing the deep learning. If you click here, and then you have to generate a code and export to the simulating all the things. And so this is the just a small things which I have explained. How the convolution neural network works. This is the image, and this is the pebble. As per like a canal, and the layer will be slide over there. Then pixel to pixel, you can do that. They have classification network into the three layers. So like that. So simple. So learning can also be done. So, so this is a very big one day is required for this. So LST and wavelet scattering can find out the features. Then you have data, neural networks, and all the things, patches size, how to train the model, for learning rate, how to calculate. Then you have a hyperparameter type of thing, and deployment from deploy the embedded systems, enterprise system. From MATLAB code, you can generate the code CC plus code, and then target hardware, depending upon your target hardware, you can generate a code. Okay, like you have to deploy the code on CPU, then if you have is required an FPGA code, and then the HDL coder is required on the CPU, then you have a HDL coders. CPU, then CC plus coders require, so like that. Or the cloud, then the AWS Docker, so you can directly do that. Hope so. Being able to explain that part. Model is there. If you just take another 10 minutes. Just remove this data. Okay, everybody. Starting with the LXNet, okay, which is the pre-trained network. If I think I have shared this code with you. So LXNet is already installed in the Deep Network Designer tab. Okay, there is no problem. So just see here. This is the classification. LXNet is, if you open the Deep Network Designer over there. Okay, so just see here. Let us classify the image using the LXNet. LXNet is a Deep Network Designer. In the convolution, so I have just passed LXNet is equal to net. Net name, we have created a net name variable. So just pass this. LXNet must be installed, that I have told you. Now see here, it's a layer 25 layer network. Input data is type, output is a object. Okay, so let us suppose you want to further knowledge about your layers. What is the first layer? What is the end layer? Okay, and further properties. So I have just used the dot notation. Net dot layers. Net is the name of variable. Net dot layers. These are the layers names which has made LXNet. Okay, so these are the layer nets, 25 layers we have in for this particular network. Okay, okay, so now see here. So yeah, further, if you want to layers one or end, if you just what is the input size or end one? What is the input size of the end layers? Just pass this. Okay. Cool. Awesome. Cool. Further properties you get to know. Okay, so you have see that 227, 227, and this is my peacock. I just test the do this analysis. Everyone, hope so all of you understood how it is going on. Okay, now I am taking one import the image, simple image. So import image has a 792 and 1056 size, but my LXNet size is 227. So I require the resize of my input data. So what can I do? This input image of peacock, I have to resize it. Okay, to 227 because my LXNet is a 227 by 227. I simply click here and it is resizable. Okay, so just be with me for the next five minutes. Okay, so yeah, so now after that, It's a resizable to the LX name. Now I'm using the simple one function that is a classify. That's name and I1 is my input image, and then I have just and I get to know what is a label. Just I use this. The answer should be become, must become. If it is come, then my LX name is working very properly. You see the categorical data and this a peacock. That's great. Okay. So now see here. Okay. Now you can choose the confidence. Now I have bring one from the three images I have bring. Okay, in my current folder it is there. Now what you can do, you can just change the value here. And again, same process you can do here. In place of I, yeah, you can do for your own images also. Okay. In place of the peacock, just change this value to the test test 2. Okay, this image I have already kept test 2, and now see what is the changes that happen. Okay, so now let's change that whether it's correctly predicting or not. Now this is the line. Okay, one can easily identify. Let us see that my table train model is identified or not. Okay. Yeah, correctly identify lion. That's fine. Now test 3. Similarly apply for the test 3 also. So you can similarly you can do that. This is the simple explanation. If you go to the this one second example, I am class Google name. Okay, so in this example, I have make a very good flow for you. Okay, so here I have kept all my trained model, SquishNet, ResNet, ResNet 50, like that. PGG16, LXNet, which I have shown just now. All the models are here. Okay, so we start with the Google link. Google link I have already installed in my PC. Okay, from the add-on option. Now see here, have a these are the options. These are the train model. Different layers. You get train on these variables. Get the link. Okay, sorry. This is my fine for my variables. I have to clearly what is the input size for the LX Google Net is 224 by 224. Okay. So now again I have to resize LXNet by 227 by 227. So these are the classes name. My model. I have to resize it. To pass this another image testing.jpg which is there here in my current folder, and see that this Google Net is identifying or not. This is my input image. Then you get to know 520 by 500. This size will not fit for the Google name. So I have to resize it to the 224 by 224. Okay, so I have done this by this command 224 by 224. Now I have used this again classify function name ID. Then showing the parachute. Still it is umbrella. Showing the parachute. What is the prediction level 24.7? Okay, was this image I have taken from the e-commerce website. Yes, this is a software generated image. But here I have to use some other models who going to predict or not. Now I have these are the things. So predicting parachute, then umbrella with the equal numbers. Parachute and umbrella in the equal number. Confusion between the parachute and umbrella is there. like that. Hope so. All of you understood this Google Net and AlexNet. And this is a deep learning model. Okay, so similarly, you can apply for the biomedical image also. So just we see, I have kept yesterday one very good source, chest volume, not here. I have one data set. I have kept, I want to show you. This. Just yes. Support by which is similarly, you can apply the classification of the retinotherapy. Okay, you see these images I have downloaded from the website. A very good example is there in the MATLAB. So like this AI model can be applied, learning can be applied to classify the disease of the retinopathy of the diabetic patients. So this is a purple, and then this is the yeah, that can also be done. Okay, so various types of the disease we can predict. Retinopathy. Hope so you understand. So I have just touched about the AI part. Deep learning where the resources are available, what is AlexNet, and the deep network designer. In the ML front, machine learning, I have touched the classification learner app, and interactively I have classified the some data set. Okay, and then initially in the morning session, I have talked about the medical image analysis, import, typeform, volume segmenter. Okay, and the other things I have discussed, and then I have shared lots of resources with you. So that the thing I have done so far. Okay, and for these examples, if you want to explore it, then again, yeah. So again, I have shared the content with you. Anything? Hello, ma'am.
Yes, sir.
Yes, Varsha ma'am, I have already covered biomedical. Okay, you are request to cover biomedical signal processing. Okay, fine. So very good question, ma'am. Yeah, these questions will be handled tomorrow. If you see that my schedule, because I am limited to the image today only. So ECG signal, EEG signal, how to understand. So tomorrow speaker Nikhil Sonone we have divided all the DP in that segments. So he will talk about the biomedical signals. Okay, so yeah, so I will just talk about here also. It's a very nice question. So now see here, yeah, here, if you join me the first day, then this is the day 3 agenda, the signal processing AI and ML for the biomedical signal. Okay, so tomorrow I request you join the session and ask the questions on the speaker itself because I stick myself to the images. I stick myself to the images only. Okay, but still, if you want, then the yeah, have here apps. Go to the app and go to the signal. Yeah, so Nikhil will be touch on this signal processing communications. Okay, so he will talk about the signal analyzer app. Okay, where how to extract the features of the signal and all the things. So it's tomorrow sessions schedule. Hope so. All of you have understood this deep neural network and all the things. And today I have shared one example. This is example if you want to explore. Yeah. So just give the another 1 minute. Okay. Yeah. Yeah. So this is the case study, especially I have bring for you. Okay. This one. This one. Classify uh, the breast tumor on the ultrasound image. Okay, so this is the very good example. Classify the breast tumor and the other thing. That examples you can take. Okay, so just one example was there. Yeah, this one. This one. Read and crop the no. Classify the breast tumor. Okay. So they also data sets are there. I request explain explore this part as well. So I will conclude my session. Okay.
Yes, if any participants have any queries, they can just unmute themselves and ask, or else put the question in the chat box.
This is the this example. Okay, so here classifications and the signals and this classification has done. I have shared with you. So this is all the data sets you can download and prepare the data label part, then create a yes, and data store the sample images. Okay, and then the segment it by the use of the apps, create a training and testing data, and like that. Okay, that can also be done.
So we have a question in the chat box.
Yes, we can. Is feature extracted in CNN? Can we display the feature extracted in CNN? Yes, we can. Yeah, we can display it and display that a feature extracted from the CNN. Yeah, if you see here. Yes, that can be done. It's a very simple thing. So we can whatever the features we extracted with a percentage of confidence, that label we can done very easily. Yes, it is done. Can be displayed. One example. Okay, I will go through the examples. Yeah. This is the example I am talking about. The way. So here you have feature extracted. So this is the we have divided not one by here, water here, here, and filling. So after training, so I have labeled the group. Now the training is there. So these are the features. Number of samples, data, define the network, classify the network, and then I have segregated. We come to the classification matrix. So PPP, F1 is code, accuracy, AUC, this is the classes name, and this is the ROC curve. Okay, that can be done. Because limitation of time, this very good example recently added. Okay, and then you can display the classes also. Okay, so the data set which I have shown to you from this example I have taken. Multi-level diabetic retinopathy from the this classification you keep. Yes, it can be done. Okay, so yeah, so what is the task for the next session after the lunch? The you have to implement this one. So go to the what is a task. If you understand my last 30-minute session, then on that you have the one hands-on exercise completely exceeding my limited time. Yeah. So this is a task, and the madam will also share the link to you. Just a minute. Those who don't know. Of course, now okay. Came here to the that. And yeah. Now, last time I also explained, go to the my course. Which course after attending the today's session we are going to implement. Okay, so yeah, so go to the home and complete these two tasks, machine learning on RAM and the deep learning on RAM. So it will give you a very good idea, feature, how to do the feature extraction, the CNN and all the things. Then go to the AI part, AI and statistics. After that, you have this course. These two courses is highly recommended for the today's session. Deep learning on RAM and machine learning on RAM. If you have a time, go for the statistics on RAM as well. Okay, this is just 1 hour and 1.1 hour course. So simply click over here and do this hands-on exercise after the lunch hour by yourself. And then when you come back tomorrow, and the Nikhil will lead the session of the signal processing and the AI, and they will talk about the biomedical signals. Thank you everyone for this. If you have any question, then ask. Otherwise, from my side, I have covered. And extremely that I have taken the 37, 34 minutes more time.
No issue, sir. It was very informative. Today's session especially was very good. If anyone wants to ask any question, please feel free to ask, or else we will conclude the session. Yes, anyone? Fill the feedback link. We have shared the feedback link as well. If you have any queries, you can post it in the feedback as well, so that we can solve the queries as well. Ankit sir, thank you so much for the 2 days sessions that you have taken. We are very thankful on behalf of Department of E&TC Engineering, Dr. D.Y. Patil Institute of Technology. I extend my heartfelt thanks, and I am thankful to you for sharing your valuable insights and expertise with us during these 2 days. Thank you so much.
Thank you. Thank you all participants. Sparing your time also. Then go to academics and research.
We will conclude the session, sir.
Yes, yes. Thank you.
Thank you. Thank you once again.